Hello and welcome. My name is Vineet Kumar Mishra and I am presenting this assignment number 1 of the heat transfer to Dr. Sasikant Yadav, Assistant Professor, Department of Chemical Engineering. So let's get started. So the topic of assignment is dimensional analysis. So before going into nitty-gritty of the dimensional analysis, let's see this famous quote. Take care of your units and they will take care of you. Take care of your units and they will take care of you. What does this mean? Like, at some time in every engineer's life comes the exasperating sensation of frustration in problem solving. Somehow, the answers or the calculations do not come out as expected, and often this outcome arises because of errors in handling of units. So, the use of units along with numbers in our calculations requires more attention than we have been giving it. In addition to this, checking the consistency of units in our equations will prove to be a valuable tool, and that will reduce the number of errors we commit when performing engineering calculations. So it is very important that we should be very careful about handling our units. So so it's a very good saying. Take care of your units and they will take care of you. Alright? Now, what are the objectives of this video assignment? First, I'll be discussing introduction to dimensions and units. Because in the dimensional analysis, our main concern, our main focus is only on the dimension. So we'll be discussing dimension and unit first. Thereafter, dimensional analysis is what actually the dimensional analysis is and how to use it, all those things we'll see in dimensional analysis. And next, we will see use of dimensional analysis, where we can apply the principles or the concept of dimensional analysis in real life. All those things we will see. And thereafter, dimensional homogeneity. What the dimensional homogeneity is, all those things with the help of example we'll see in upcoming slides. And methods of dimensional analysis also, different methods of dimensional analysis. And last but not least, we will see example problem. Alright, we'll see an example problem. So first of all, dimensions and units. Why we study dimension and units? Because engineers and scientists have to be able to communicate not only with words but also by carefully defined numerical descriptions. Alright, so in dimensional analysis, we are only concerned with the nature of the dimension, that is, its quality, not its quantity. Its quality, not its quantity. Means we are always trying to reduce the number of variables. We are always trying to reduce number of quantity. So we are mainly concerned its quality, not its quantity. Okay. So what are the dimensions? Dimensions are properties which can be measured. So any property that can be measured is called dimension. Suppose mass. We can measure mass in kilograms, grams, pound. So mass is a dimension. Similarly, length. We can also measure length in meters, centimeter, feet, inch, whatever. So length is also a dimension. Similarly, time. And there are many other dimensions like temperature, pressure, and many other. So, and to express these dimensions, we require units. So, what are units? Units are the standard elements. Units are the standard elements we use to quantify these dimensions. Units are the elements we use to quantify these elements. Alright, for example, to quantify the mass, we use kilogram. We can also use gram, pound, depending on our system. In M case, I'm talking about to quantify the mass, we use kilogram. Similarly, to quantify the length, we use meter for time, seconds, and etc. etc. So, dimensions are basically of two types, the fundamental dimensions and the derived dimensions. So, here we can see that the fundamental dimensions are like mass, its unit is definitely kilogram. I'm talking about MKS. Sorry, yeah. So, the following fundamental dimensions are like mass and 1 second, like mass, dimension m, and the unit is kilogram in mks, meter kilogram second. For length, it is meter and dimension is l, time second, and dimension is t. Sometimes we can also take temperature as a fundamental dimension whose unit is like degree centigrade and theta. Alright, or t. So these are the fundamental dimensions. Dimensions are of two types, fundamental dimensions and derived dimension. We have seen fundamental dimensions. In the upcoming slide, we will see the derived dimensions. So dimensions are basically important. Alright. Now, secondary or derived dimensions. So what are the secondary dimensions? Secondary dimensions are those quantities which possess more than one fundamental dimensions. Means when fundamental dimensions are combined together, then we get secondary or derived dimensions. For example, area. So what is the formula of area? Alex, area is the length into breadth. Okay, length is again measured in meter, so it is L, and it is also L, so it is basically L square, right? So this is what written here. Similarly, if we talk about like velocity, so what is velocity? Velocity is simply speed per unit time, like distance per unit time. Distance per unit time. Distance we measure L and this is we measure T. So this is basically LT minus 1. Alright. Similarly, for the acceleration, velocity per unit time, force and density, like sorry, okay, for example, density. So density is mass per mass volume divided by volume. We know mass m and volume L cube, so this is simply ml minus 3. Alright, so basically what I'm trying to say is that secondary dimensions are those quantities which possess more than one fundamental dimensions. When fundamental dimensions are combined together, then we get the secondary or the derived dimensions with examples like area, meter square, volume, meter cube, velocity, acceleration, force, density, and there are many more, to name a few here. Okay, so next, now here we are. What actually the dimensional analysis is? What is the objective of dimensional analysis? What is the importance of dimensional analysis? So, dimensional analysis is a means of simplifying. Again, dimensional analysis is a means of simplifying a physical problem. Means we apply dimensional analysis to simplify a physical problem. How? By appealing to dimensional homogeneity. By using dimensional homogeneity. Now, what actually the dimensional homogeneity is, we will see in upcoming slides. But as for now is concerned, dimensional analysis is a means of simplifying a physical problem by appealing to dimensional homogeneity. to reduce the number of relevant variables. Means we apply dimensional analysis to solve any physical problem with the help of dimensional homogeneity to reduce the number of relevant variables. And it is a pure mathematical technique. It is a pure mathematical technique to establish a relationship between physical quantities involved in a physical phenomena by considering their dimensions. As I have talked earlier also that in dimensional analysis we are mainly concerned with the dimensions. So it is a pure mathematical technique to establish a relationship between physical quantities involved in a physical phenomena by considering their dimensions. No, to describe in a nutshell, the object of dimensional analysis. The object of dimensional analysis is to reduce the number of parameters in a problem. Why we do so? For ease of calculation and experimental economy. For the use of calculation and experimental economy, it follows that the best analysis will produce the minimum number of non-dimensionless groups. As why non-dimensionless groups? Because as these groups have physical significance and the non-dimensionalizing technique must always produce the correct scaling groups. And it might also be expected that the method should be applicable to wide range of problems. The point to be noted to note here is that the method should be applicable to wide range of problems. Job problems. And the technique must be concise, correct, and consistent. Technique must be concise, correct, and consistent. Okay, so the technique of dimension analysis should be concise, correct, and consistent. Alright, so basically, what we do, we just generally try to reduce the number of variables in the dimensional analysis with the help of dimensional homogeneity or any other such means. Alright. Now, what is the application of dimensional analysis? Dimensional analysis is mainly applicable to research and development areas like presenting and interpreting experimental data. Also, attacking problems that are not amenable to direct theoretical solutions. Means the problems which cannot be directly tackled with the theoretical basis. For that we require dimensional analysis. And also checking equations, its dimensional homogeneity, consistency, and all those things. So dimensional analysis also help us in that checking equations. In establishing the relative importance of particular physical phenomena. And last but not least, physical modeling. Now I'll try to explain this with the help of an example. Suppose we have a long smooth cylinder, something like this. Okay. So the drag force per unit length on a long cylinder. So the drag force per unit length on a long smooth cylinder is function of. Now suppose the drag force per unit length F. On what kind of variables it will depend? It will depend on airspeed U. Okay, airspeed U, density rho, diameter d, and viscosity mu. Okay, so there are 5 variables. One is dependent variable and other 4 are independent variables. So we have considered a smooth cylinder, and the drag force per unit length will depend on airspeed u, density rho, diameter d, and viscosity mu. However, instead of having to draw hundreds of graphs, portraying its variation with all combinations of these parameters. Now if we want to draw the variation of drag force, so we have to draw a number of graphs with all the parameters like for with the speed of view, density, diameter, viscosity, and all other things. So dimensional analysis can tell us that the problem can be reduced to a single dimensionless relationship. Dimensional analysis can help us to reduce this problem to a single dimensionless relationship. And what is that dimensionless relationship? We can simply write CD is equals to function of RE, where CD is the drag coefficient and RE is of course the Reynolds number. Okay, so we have reduced our 5 variable problem to 2 variable problem and non-dimensionless group. So we have seen in this instance that dimensional analysis has reduced the number of relevant variables from 5 to 2, and the experimental data to a single graph CD against RE. Now if we want to plot CD versus RE, so we need only one graph, okay, instead of having hundreds of graphs. So so as you can see that this has helped us in reducing the number of variables, okay, and thus made our calculation very easy. Thank you.